Hello ladies and gentlemen, welcome to the next installment of Flipped Classroom Lessons. Tonight we're going to be looking at how can we find the limit of a function by looking at the graph. First we have to understand what a limit is. So a limit is the idea of looking at what happens to a function, what happens to the y value as you approach particular values of x. So symbolically we would write it with an LIM for limit. So we would read this, the limits of f of x, as x approaches a, whatever the value of a is. And we would say that the limit as x approaches a is L, whatever that number is. So let's take a look at a graph and see if we can find the limits. So if we look at this graph, we want to find the limit as x approaches 1. Well, in order to do that, we've got to trace one of the lines or curves in the graph. Well, the only line or curve that approaches x equals 1 is this red one here on the left. So as we follow that along, as x approaches 1, what happens to y? Well, x approaches 1, y is 0. If we again look at this, if as x approaches 0, what's the limit of the function? Well, as x approaches 0, y will be negative 1. The next thing is evaluate f of 2. So when x is 2, what's y? Well, you have the open circle at 1 and the closed circle all the way up at 4. Well, that's f of 2. So f of 2 is 4. And then if we look at f of negative 1, when x is negative 1 here on the left, y will be negative 2. So it's important to understand with looking at limits, the function doesn't actually have to get to that number, but that's the value the function is trying to attain. So if we continue to look at this graph here, if I would ask you what's the limit as along here as f of x as x approaches 2, if you look at this from this direction, it's trying to attain a value of 1. It doesn't quite get there because there's an open circle, but we could say that the value of this function along this line, the limit of this function, is 1. Let's take a look at another one. So we're going to use this graph to find the limits or the values. So if we take a look at this, the value of this limit, f of x, as x approaches 1, so as we trace along here, as x approaches 1, about right here, x will be 2. Y will be 2, excuse me. As x approaches 1, y is 2. And so we would say that the limit of this function, as x approaches 1, the limit is 2. So now on B, what's the limit of f of x as x approaches negative 1? Well, negative 1 is here, and we're going to trace the line along. So the limit as x approaches negative 1 is 0. On this part C, I'm asking you to evaluate what's f of 0. Well, x is 0. Y will not be the open circle. Y will be 2. That's the closed circle. If I ask you to evaluate f of negative 1, that will be 0. So if you need to go back and rewind this and replay this, you should do so. We're going to do one more example. So let's take a look at this graph. We have a parabola and we have a line. There's an open circle there, a closed circle down here. So if I would ask you to evaluate the limit of this of this function f of x as x approaches 0, we need to trace along this curve, and when x is 0, y is 1. That's the limit of the function as x approaches 0. So as x approaches 3, this ends here. We can't get to x is 3 on this curve. We now have to jump down to the line. So as x approaches 3, y is 0. That's the limit of the function as x is approaching 3. So now I'm just asking to simply evaluate f of 0. F of 0 will be 1. And here again I ask you to evaluate f of 2. Well, when x is 2, if you look, you have a closed circle at 1 and an open circle up at 5. So the evaluation, when you evaluate the function f of 2 is 1. So it's important to remember when we're looking for the limit of a function, we're trying to get from the graph the value that the function is trying to attain as you approach the value of x that you're given. So keep that in mind. We'll be going over this on Monday. So I hope everybody enjoyed their long weekend. And this is the end of this installment of Flipped Classroom Math 12R.